Two instruments are used to measure the height h of a tower. The error made by the less accurate instrument is normally distributed with mean 0 and standard deviation of 0.0056h. So the less accurate instrument is approximately normal with mean of 0 and standard deviation of 0.0056h. Right? And then the error made by the more accurate instrument is normally distributed. So more accurate is normally distributed with mean of 0 and standard deviation of 0.0044h. Okay, the errors from the two instruments are independent of each other. This is going to come up. Calculate the probability that the average value of the two instruments is within 0.005h of the height of the tower. So we're looking for the probability that the average, right? So this will be negative 0.005h less than or equal to the average, which will be L plus M over 2. And this is less than or equal to 0.005h. So we want the probability that the average is between the 0.005h. So equals question mark, right? Okay, so we need to find the mean for this distribution, L plus M over 2, and the standard deviation for this distribution. So let's go ahead and find the expected value of L plus M over 2. So with the expected value, we know we can take out any constant. So this is equal to 1/2 the expected value of L plus M. And with expected value, we can separate these, right? This is equal to 1/2 the expected value of L plus the expected value of M. And we know the expected value of L, that's just 0. And the expected value of M is also 0. So half of 0 plus 0 is just 0. So we know the mean of L plus M over 2 is going to be 0. Now let's find our standard deviation. The way we can do that is we can find the variance of our distribution L plus M over 2 and then take the square root of it, right? So the variance of L plus M over 2. So we know the variance of something with a constant, we can take out the constant, but we have to square that constant. So this is equal to the variance 1/2 squared, the variance of L plus M. And now this is where the independence comes in handy, right? Since they are independent, we know that the variance of L plus M is just the variance of L plus the variance of M. So this will be 1/4 the variance of L plus the variance of M. Okay? And we had the standard deviation of L, which was 0.0056h. So this is just equal to 1/4. So the standard deviation, so all we have to do is square this number, right, to get the variance. So that's 0.0056h squared plus the variance of M will be that squared, right? So 0.0044h squared, right? And if we were to do this calculation here, we would get 0.000013h squared. So we know that the variance of L plus M over 2 is that 0.000013h squared. So this means the standard deviation of L plus M over 2 is just going to be the square root of the variance of L plus M over 2, which is equal to the square root of 0.000013h squared, which is going to be 0.003606h. All right, so now we have our distribution for L plus M, right? L plus M over 2. So this means that L plus M over 2 follows a normal distribution with a mean of 0 and a standard deviation of 0.003606H. All right, now let's find our probability, because we can standardize this now, right? So the probability that negative 0.005H, right, less than or equal to L plus M over 2, less than or equal to 0.005H. This is equal to the probability, so negative 0.005H minus the mean, which was 0, over the standard deviation, which is 0.003606H, less than or equal to Z, less than or equal to 0.005H minus 0 over 0.003606H. Now, let's find these. So these H's are going to cancel, right? So we're going to just have constants, which is nice for our Z table, right? So this is the probability of negative 1.39 less than or equal to Z, less than or equal to 1.39. And we know this is the same thing as the probability of the bigger one, right? So the probability that Z is less than or equal to 1.39 minus the probability that Z is less than or equal to negative 1.39, right? Since we're trying to find the probability between, so let me draw a little picture. So we're trying to find the probability between negative 1.39 and positive 1.39, right? So we're trying to find this here. So what we're doing here is we're doing the probability that Z is less than or equal to 1.39. So let me get that. So that's this green, right? Minus the probability that Z is less than or equal to negative 1.39, and that's this brown here. So the green minus the brown is the thing that we're looking for in the middle, right? So that's the idea there. Okay, so let me go back to black. So this will be equal to, so let's go to our table. So negative 1.39, let's go ahead and do that first since we're here. So negative 1.3, oh, I don't want all that. Let me get rid of that. Negative 1.3, oh, whatever. Negative 1.3, and then 9 is over here. So 0.0823, so 0.0823, so 0.0823, and then this guy over here, the positive, let's go here, 1.3, so 1.39, so 0.9177, 0.9177, and this is going to be 0.8354. So the probability that the average, right, is between negative 0.005H and positive 0.005H will be about 83%, 83.5%. So that is closest to our value